Um, well, nice to see you all after so many virtual meetings. It's nice to see people in person again. So, quick intro. I had the privilege of spending almost my entire career in open source, and during this time, I worked with two of the best open source marketing managers, bar none. One of them told me that not introducing yourself is cardinal sin of marketing. So that's my intro. I pretty much did open source for the last 20 years. I was an embedded engineer by training. I'm the Ceph platform director at IBM and Red Hat. Before that, I was the Ubuntu server PM at Canonical. And before that, I was the dreaded, apparently, systems management czar at SUSE. I was also the maintainer of Man for about 10 years. And that's enough about me.
Hey, I'm Sage McTaggart, and I work on cybersecurity for Ceph and ODF at IBM. I have an interest in security that ranges from the theoretical, formal languages, all that fun stuff, to the practical, such as storage systems and incident response. And in my free time, I love hiking and gardening.
And your dog.
And my dog.
So we're obviously going to skip the intro slides, but there is one thing that I wanted to show you. This is a slide that we made for IBM's management. Well, we now use it for customers too, but it was mostly internal pitch for IBM to invest in Ceph. It's a history of Ceph. You don't need that. The interesting bit is the stuff in the corner, which is the estimate of the market size, which I do twice a year. So because of Yarit's telemetry, you know how many exabytes of Ceph storage are actually pinging back and reporting their existence. Because I also know about the customers, and because I also know about the ones that are not customers, I can actually compile a pretty reasonable estimate that we're between 4.2 and 6.5 exabytes of Ceph out there. So I don't know if that makes us the largest software-defined storage product, but I think that it makes a pretty credible case that we're the largest software-defined open source thing out there. So that seems worth celebrating. Now let's go security. So security practices harden a specific point of your infrastructure. Cherry-picking practices without a model of the threat and the attacker is not a viable strategy. The joke usually goes, if you want to protect from all possible threats, just cover your computer in concrete, drop it at the bottom of the ocean. That is not very useful. So your security model needs to be defined in the context of a threat model. Are you facing script kiddies or the GRU or the dreaded privileged insider? These are very different scenarios, and as much as management may like to say protect against everything, if you have no priorities, then nothing is a priority. If everything is urgent, nothing is urgent. So you have to pick your battles. Once you have a threat model, you can start diving in and applying the right security practices, whether you have a STIG or you just have best practices for security. Now, let's look at this network part. The public security zone is an entirely untrusted area of the cloud. It could be the internet as a whole or just networks external to your cluster that you have no authority over. Data transmissions crossing this zone should make use of encryption. Note that the public zone, as I just defined it, does not include the storage cluster front end. In Ceph, this is called the public_network, which defines the storage front end and properly belongs in the storage access zone. Ceph has this set of network zones, and they help you a lot in terms of defining the security of your cluster. The Ceph client zone refers to networks accessing Ceph clients like the object gateway, the Ceph file system, or block storage. Ceph clients are not always included from the public security zone. For instance, it's possible to expose the object gateways, S3, or Swift APIs in the public security. Next, the storage access zone is instead an internal network, providing Ceph clients with access to the storage cluster itself. And finally, the cluster zone refers to the most internal network, providing storage nodes with connectivity for replication, heartbeat, backfill, and recovery tasks. This zone includes the Ceph cluster's backend network, called the cluster network in Ceph. Operators often run clear text traffic in the cluster zone, relying on the physical separation or VLAN separation of this network from all other traffic. This is a good example of what I was saying before. This choice would not be good if your threat model includes an adversarial privileged inside. But if you're protecting from script kiddies, sure, save a little bit on the hardware and don't encrypt that traffic. These 4 zones are separately mapped or combined depending on the use case and the threat model that you're using. Now, components spanning the boundary of 2 security zones with different trust or authentication requirements must be carefully configured. These are the natural weak points in network architecture. Well, they're not necessarily weak, but they're the natural points to attack because they cross different security zones. So if you find an exploit in one of them, you can cross to a higher level of privilege. And so they should always be configured to meet the requirements of the security requirements of the lowest access zone. In many cases, the security controls should be a primary concern due to the likelihood of probing. Operators should actually consider exceeding zone requirements whenever possible at these integration points, which for a storage product is actually easier to do than for most compute products. So it's not the general case of an operating system. This is a storage platform. It does very specific things. So it can be done more often than you would expect. For example, the cluster security zone can be isolated from other zones easily because there is no reason for it to connect to other zones. Conversely, an object gateway in the client security zone will also need access to the cluster security zone's monitors to get the cluster maps and to all the OSDs, and will likely expose its S3 API to the public security zone to serve data, unless you have an HA proxy front end. So we have all varieties in our collection of daemons. And the important thing here is don't apply one policy to all. Use the most secure policy that you can for each daemon. And don't run daemons that you don't need, obviously. If you're not serving file object and block, why running daemons that you're not making use?
So, some things that people might be interested in hearing about are how we've moved companies as an open source product. Last year, well, a little bit over a year ago, we moved to IBM, and the security of a product, you know, this is all very important, how we implement it, but what about the support of a product? Do you really want to maintain and patch an unmaintained product upstream? Probably not, though some of us might. So I'm going to discuss a little bit of IBM product security, how it's been going, some of our accomplishments, and what we're planning on doing going forward. So, of course, product security at IBM performs secure development and lifecycle activities across the lifecycle of each release. The goal is to reduce risk and improve security for Ceph, Rook, and many other products. We suggest improvements, we pen test, we manifest all of our dependencies, we review vulnerabilities, we track weaknesses and exploits. We approve errata releases, security bulletins, etc., checking all the details, checking every new library for CVEs. So we find these vulnerabilities, we find them in upstream Ceph, we fix them in upstream Ceph, we spread open source within industry. So we've been manifesting and documenting all of our dependencies. We've automated security scans of our code. Many customers want clean scans, so we're trying to reduce even low-risk vulnerabilities in addition to compliance there. Fully onboarded with IBM pcert, we're fixing all prior vulnerabilities, no matter how low risk. We're working on automatically updating most, if not all, dependencies. We're starting off with the ones with the most CVEs per release to reduce our exposure. So for example, our next new release is going to automatically update Grafana with every release to the latest minor release. That might seem like a trivial thing, but Grafana, they do a great job finding their CVEs in their product. There are many CVEs that we then find out about. And if we were to automatically update it constantly, it might break things. So we're finding ways to do this starting with the low-hanging fruit and the ones that have the most CVEs per product. per release. So this will reduce our number of CVEs. It will create clean scans, which are increasingly becoming something that customers ask us about. So of course, we're continuing to do our existing process of reviewing existing vulnerabilities, releasing regular security updates, and improving code security preemptively. We've gotten a lot of upstream engagement. We're getting many more reports than in the past. Some cases, hundreds of vulnerabilities per report. In other cases, a dozen new CVEs from people reporting to upstream. All this within the past year. We've implemented changes based on these customer and upstream requests. And we're going to continue to follow IBM standards to fix vulnerabilities, ensure compliance, ensure we're fixing all CVEs. Goal to be fully within IBM SLA by end of year, optimistically. And we're going to continue working to fix problem libraries. We've created a pipeline to automate code scans to detect new vulnerabilities. And again, this applies to both IBM Ceph and upstream Ceph. So all of these fixes, they're ported to upstream, they're ported to the open source. I mean, obviously Ceph at IBM is open source, but our main upstream Ceph. We're going to continue to support all of these versions of Ceph. The new collaboration produces, of course, new challenges and new goals. But the benefit here that we're seeing is a lot more collaboration with the open source community and a lot of continued progress there. Some other things that we're doing, we're working to improve dashboard security. We work to improve the call home functionality and security for IBM support there by applying open source principles. If we're hearing about a vulnerability, if we're hearing about something that's insecure, we want to fix it. These things shouldn't just be hidden. They should be fixed publicly. So we're also continuing to work on using Ceph as a backend for AI, government clients, all these other users of Ceph. And as always, please feel free to reach out with what you want to hear from our collaboration, discuss any concerns, and let's continue to all collectively make Ceph the best it can be, the most secure it can be, and address security concerns from the community. So some other things we're working on, we're working with IBM Research to discuss quantum and confidential computing. We're currently determining the viability. We're determining where we're using cryptography, how we can make it more quantum safe, and working with open source research there. The goal with all of this collaboration is that the upcoming research is open source, and that any products and any parts that we're using within Ceph are open source. So, yeah. We also have a little bit about how we do encryption and key management. Again, server-side operators overwhelmingly choose to encrypt data at rest using LUKS. All data and metadata of a Ceph storage cluster can be secured using dencrypt configurations. This may not be the default, but it is certainly an option. Almost all customers choose to do so. We also enable security best practices by locating our monitors on separate hosts from the storage daemons. And this ensures the anti-affinity of the keys and the data that they encrypt. This means that if a driver host that is stolen, it is physically separated from its decryption keys. This is a security best practice. The object store gateway also has some additional capabilities, including encryption at ingestion time, the use of per user keys, not just per drive. We have key rotation with tools like Vault. We have support for Amazon AWS key management systems and more. We support FIPS 140 ciphers, and they can be used as long as they're provided by RHEL in the appropriate versions. And for encryption in transit, we allow Ceph's internal protocol to be encrypted under Messenger version 2.1 protocol. We do still allow the legacy clear text protocol, but again, this is really going to depend on your use case. It is an option. We have the security zones for a reason. Some people, though, they'll say, hey, we want to have this encrypted, and we have Messenger version 2.1. Again, this ensures that if you are not satisfied by the physical or logical isolation from access, you have the encryption as an option. And of course, one might worry a little bit about the performance, but for a properly designed cluster, the performance impact is insignificant. Latency is overshadowed by network communication as long as the CPU overhead is accounted. So what about Rook? Rook can use CRDs, custom resource definitions, to encode many of these settings. We can configure our trust certificates for RGW's web server. Rook also supports at-rest data encryption, as we discussed earlier, with in-flight Ceph protocol encryption as of 1.9. Kubernetes permission systems also applies to persistent volumes, our permissions quotas, all that comes from Kubernetes. Nothing Rook needs to do here. Rook supports key management systems in the CSI, allowing individual volumes to be encrypted with their own key. This ensures the best practice of ensuring limited scope per key. We can follow best practices easily, key revocation, and limiting scope from each key. This really limits the scope of our unencrypted traffic, and it also limits the scope of each key, so if an individual key is stolen, it has a very limited scope. And going on to the control plane, of course, SSH is used by Ceph admin, Ceph Ansible, and other deployment and day one tools to provide a secure command path for upgrade and install as part of host management. We do this so that our dashboard isn't exposed to the whole world, the whole internet, but it can be reachable by the operator's workstation, so it can be of use. The manager supports the whole infrastructure. It needs to be accessed on the storage access zone, hence why we use SSH. In terms of identity and access, Ceph's use of shared keys protects clusters from man-in-the-middle attacks by default. Good practices are still needed. A good practice here, you want to grant your keyring read and write permissions only for the current user and root, with client admin user restricted to root only. This prevents all users from being root as per our best practices. Talking now a little bit about RGW and best practices here, it supports the key and open secret model of AWS S3 and the equivalent model for OpenStack Swift. And of course, we still want to treat our administrator key and secret with appropriate respect, using the administrative users sparingly to reduce the risk profile. Ceph's user data is stored in Ceph pools, which of course should be secured, as we've discussed regarding our data at rest. We can also comply with OIDC providers such as KeyCloak, backed with your organizational identity provider for an even better granular role or attribute access. And we're also working on improving our access and dashboard. I'm not going to say too much about it because we're still working out the details, but we're looking at how to improve it with use of your organization's credentials so that we don't have to worry about creating users by default. That's the end goal. We'll see where it goes over the next year. You'll hopefully hear an update on that soon. And we also support LDAP, Active Directory users. We always recommend secure LDAP. We support OpenStack Keystone to authenticate object gateway users in OpenStack Cloud. And of course, in addition to identity management, auditing is an important part of security. Operator actions against the cluster are logged and should be periodically removed, as well as aggregated to your log management system as appropriate. You can see an example of a log right here. And we also should probably cover some stuff about data retention. Once data, do you want me to finish or do you want to? Okay, and I'm going to hand it over to Federico.
Thanks. So once data is deleted from a Ceph cluster, it generally cannot be recovered for practical use. But there are exceptions. RBD has a newish facility called a trash bin, where you can dynamically use spare capacity to retain images that have been deleted until the capacity is needed or until a certain amount of time has passed. And similarly, in RGW versioning, the versioning of object store buckets may result in you retaining in the history an object that you have since deleted. So the lesson here is that when user data is a concern, you have to configure the storage pools accordingly. You cannot just take the defaults. Additionally, individual data blocks that used to constitute an object may still be present in the storage medium, like in any other storage technology. You cannot just write a lot of data to a Ceph cluster to overwrite your data for safety. That's not going to work, or rather, it's not going to work consistently, which is what you care about in security. The right solution here is, again, do the right thing. use at rest encryption, and when you need to sanitize the medium, you throw away the key. It's fast and it's simple. Plus, a lot of hardware does that for you already, so you don't even need to manage it. There is another aspect here, which is, so the typical scenario is that you need to sanitize the disks because you need to return them for RMA. They failed, they're under warranty, you need a replacement. Unless you are very special and you have a contract, I don't know, you're Google and you have a contract with Seagate that says do whatever you want, most of us have to return intact drives. You cannot shred them. Probably, maybe you can degauss them, but usually you can't do that. You cannot use a shotgun. They have to be drives still when you return them. So the encryption is really the most reasonable solution. And the other scenario where this comes in play is the opposite one, where somebody is trying to cryptolock you for a ransom. And so what do you do to prevent unwanted encryption? And there, the typical thing that comes to the rescue in Ceph is that you can use multi-factor authentication in RGW to make it harder to carry out these kind of operations. You require a second factor for these paths so that it cannot be attacked that way. One more thing, which are infrastructure hardening. So hardening options are very highly vendor dependent. These are IBM and Red Hat's choices. I want a single distribution for all of our 5 lines of business. So the binaries are as identical as we can make them with 2 different build systems. We don't want to go into the GCC and kernel options. This has been already long enough day. But on the left are the things that come to your binaries from GCC. Those are our choices. On the right are the things that come to you from the kernel. Those are RHEL's choices. You can rebuild the Ceph binaries, of course, and you can rebuild your kernel if you have enough time. But what I'm advising is not to do that unless you really want to. What I'm advising is that you should know what hardening was done to your kernel and to your binaries. That really should be minimum homework. And on the other front, SE Linux is running by default on our system, and that shouldn't come as a surprise. I guess it's Red Hat coming through the IBM patina. SE Linux is a religion at Red Hat, so we make no apologies for that. And then FIPS 140 is required for government customers, and as Sage was saying, you can do that by choosing the right versions of RHEL. You can play with things like seccomp, pi, and the various ASLR options, but really, if you're using RHEL or Ubuntu or a major Linux OS, they tend to be already set for you. Still, I recommend that you know what is there because these prevent most buffer overrun and heap overrun attacks, so they're kind of good hygiene. That is the end, except we have some resources for you. So first one is from Acquia Security. It's a tutorial on how Kubernetes secrets work. If you know Kubernetes and you know secrets, you know that they aren't, at least by default, right? So you need to harden Kubernetes secrets. That is a good short explanation of how they work. Hacking Kubernetes is an entire chapter dedicated to storage. That's Michael Hausenblatt's latest book. That is very Rook-centric, obviously, but it's very, very good. The security and hardening guide is part of the IBM and Red Hat product, and it's basically a long-form version of this talk. It contains most of the stuff that we're discussing here. Encrypting secret data at rest is another interesting tutorial on Kubernetes secrets, kind of hammering on that point because really the default Kubernetes secrets are not acceptable. You need to put in place a strategy for Kubernetes secrets. And the compiler and GCC things. So here there are 2 things. One is that link. The other one is, I ran out of space, but there is a page on Ubuntu security team has a page with all the kernel hardening options. So you can look them up there and you know what they do. And then regardless of what Linux you're using, you can then go look at your kernel and see if you have them or not, if they seem interesting. These are all the people that worked on this presentation over time, and that's it.